it was 2017, right? People were doing ICOs claiming to like, we're going to disrupt the real estate industry. We're going to disrupt the insurance industry. You know, we're, you know, going to replace, you know, Visa. And then I'm like, okay, great. Like I didn't think my cat game was going to break the whole network, right? And so you're right. Like in retrospect, like the fact that these cats live forever and
I mean, it was
and they just reproduce.
Brilliant marketing, you know, like incredible.
It's probably true. I think if it hadn't been as bad, it wouldn't have been as good.
Yeah, it's definitely a feature more than a bug.
So I don't know actually the name of this podcast. We are shooting this episode just because we are currently at Edge Esmeralda in Hillsburg, California, an amazing community gathering with a lot of researchers, technology enthusiasts, and people that want to kind of leverage this kind of technology to have like a positive impact in the world. Speaking about community, that's how we met, Louis and I. We met in a community in France called Fetopia, created by Jessica Angel and Primavera De Filippi. Jessica Angel working on amazing new way of living and community living, and Primavera also contributing to this, but also originally part of the Harvard blockchain research pool and CNRS in France, working on all the blockchain and decentralized and governance topic. And I think Primavera invited you, right? That was how you discovered the community, and that's how we met. And we used to live together a couple months per year in this castle, in this community living castle. I have the pleasure to introduce you to Dete Shirley, who is the chief architect of Flow Blockchain, but also the co-founder of CryptoKitties. He also co-created ERC 721 and then created Flow Blockchain to fix all the complicated things that he faced while he was doing CryptoKitties and this standard, and also contributed to this native language called Cadence, which is the native language of Flow. And we are really happy to welcome you right now because we are going to make like an amazing new network upgrade called Crescendo, bringing an EVM zone to the Flow blockchain, but also like many other like amazing new features that mostly the idea is to release all the work that we've done to a broader audience and making it like easy and accessible to everyone to leverage this amazing work that we're doing in the shadow for the last 2 years. And we also have the amazing pleasure to have Matt, one of the community enthusiast member that is vibing with Flow and also ETH community, and hopefully soon ETH and Flow will be one big community. Based on that, I don't know where I'm going right now with this sentence, but potentially we can start with you, Dete, and by like speaking about introducing a little bit more why you built Flow, and potentially also starting to jam all together about what's the benefits for an expert in solidity like you to discover this kind of topic.
Yeah, so I mean, the story of Flow is pretty straightforward, right? We built CryptoKitties. It overwhelmed Ethereum. We attracted a bunch of investors, and we got a lot of interest from various IPs, including eventually NBA, which we did a partnership with, and who said, "Hey, you're attracting a general audience with this, with your product and this technology. You know, we want to be a part of that." And as the CTO of that newly formed company, I took very seriously the idea of, well, what blockchain are we going to build on? Because Ethereum wasn't the obvious answer, given that, you know, with just, 100,000 DAUs, we had completely overwhelmed the network, right? We represented about a third of all the gas on Ethereum for 2 weeks. And, if we wanted to go to a million DAU, let alone 10 or 100 million DAU, it wasn't going to scale. The scaling story of Ethereum at that time was sharding. I was and still am very skeptical of sharding, because I think that the value of smart contracts being in the same atomic call space is so great that you either have to do, what Near eventually did, and Near didn't exist back then, but what Near eventually did, which is to say, look, anytime you make a cross-contract function call, it's got to be asynchronous, or everyone's going to want to try and be in the same shard as everyone else, and having all those shards is going to end up being sort of meaningless. And so I really wasn't sold on the idea of sharding. And so we went and we talked to, I don't know, we probably read, collectively there were like 3 or 4 engineers and I, and we probably read 100 white papers. We talked to probably 20 teams who were proposing various blockchains and whatnot. And in the end, we're like, hey, like, we need to go our own way. And there are lots of things about Flow that I find very interesting, and we could talk about why it scales differently without sacrificing decentralization. But where I wanted to talk to you about was a decision we made later, almost a year later, maybe even longer, when we were starting to think about what the runtime would look like. And by that time, right, we'd built CryptoKitties. We built a follow-on project called Cheese Wizards. And in a nutshell, Cheese Wizards was a rock, paper, scissors tournament where, and it was all themed around these wizards that were literally made of cheese. But fundamentally, the gameplay was rock, paper, scissors, and then there was a tournament structure to it that was sort of battle royale style. And I was a contributing engineer on both those projects. And Cheese Wizards just about finished me. The limitations of Solidity, the undocumented side effects in Solidity, the subtleties that you have to understand about how the runtime works, the fact that you have to drop into assembler for certain, in order to get performant functionality in certain things. I was just like, I was fed up with the idea of EVM. And so I started talking to our various advisors and friends in the ecosystem about, what do we want to do? Because I'm not sold on EVM for our blockchain. We spent a bunch of time looking at WASM. My opinion of WASM was then, and to a certain extent still is, although less so, is that it's the wrong technology for blockchain because it was built for a different purpose, right? The reason WASM was built was, hey, we want to run web-style software on the client and have that be secure from the rest of the computer. Whereas in a blockchain context, you need the smart contracts to be secure against each other. And inside WASM, the normal WASM runtime, there's no memory protection. It's just a flat memory space, and you can read any memory in the WASM runtime that you want and write to any memory that you want. And so if you want to have protection between smart contracts, you need to have multiple WASM instances. And it sounded like that wasn't a scalable answer either. So we were talking to one of our advisors, and they're like, well, just build your own language. I'm like, are you crazy? Like, why would we do that? And he's like, well, you're telling me that nothing else does what you need it to do, so why don't you consider that? And I'm like, okay, fine. And so I talked to one of the members of our team, an engineer named Bastian, and Bastian had joined us for actually as an iOS developer, but it turned out he had a master's degree in computer languages. And so he and I started talking about languages, and he did a bunch of research, and he found this research out of Carnegie Mellon that basically was like, hey, if we introduce this thing called resources, what ended up being called resources, I don't think they were called that in the initial paper, but we can design a programming language where the objects of value, right, the tokens in the blockchain are actually represented as data structures, protected data structures in the language. And then we can pass those things around the way we pass data structures around. And if the language and the runtime are protecting the sanctity of those things, it makes for a much easier effort in programming. And so, when I saw that, and that, by the way, that same researcher underpinned the Move language that was used in the DM blockchain that Facebook built, that is now known as Aptos and then Sui, which is a fork of that. That really triggered my mind. I was like, this is going to be a better way to write code. And so we went through a design process for Cadence where basically I would write pseudocode and of hey, I want to write my code like this. And then I'd send it to Bastian, and then Bastian would email me back and he'd be like, well, That's impossible because what you're doing here is, it's ambiguous. And in this case, you're using this symbol to mean this. And in this case, but basically he formalized all of these ideas. And so what we have in Cadence is the first smart contract programming language that was co-designed by somebody who had written smart contracts before. And it's kind of astounding that that's not true of other languages, but it isn't, right? Like, obviously, you can't blame Solidity for being written by people who hadn't written smart contracts, because that was the very first smart contract programming language. But it's kind of wild that that the team that built Solana and the language on that, and the team that built Move for Facebook, they didn't come from Web3. That they came into Web3 and then sort of said, hey, this is how you should write programs. Whereas we went from application developers and said, what do we want? And we built that. And so, so I don't really know where to start, because there's a lot of aspects of how the Cadence language works, right? The data structure, the protected data structures that I talked about that automatically manage the concepts of ownership and access control. But even then, since we were introducing a new language, we have a new transaction format, which I think is really interesting. We have a different account model, which is really interesting, where your assets live in your account rather than just being referenced, living in a smart contract and referencing back to your account. And so, I kind of would just like to have you drive through some of these ideas and see where your curiosity takes you.
Sure. And I guess I'll provide like a little bit of context on, where my ideas like come from in relevance to this. So for the first part, actually, I don't know pretty much anything about Cadence, so this will be a good, perhaps, first initial conversation of like talking about it.
It's great.
Secondly, my background is more in like Solidity development and dealing with the EVM. So like, I understand some of the pain points you're bringing up of, like kind of trying to do like, certain very specific and fine-tuned things within the context of Solidity on the EVM. And also like to secure these things can often be, like a lot of work and overhead kind of dealing within the language. Also like how things kind of like compose and scale is also like another consideration. So yeah, I'm familiar with that from like the EVM context for sure. And also see, like the importance of having like a DSL for, for whatever particular type of programming you're trying to do, especially perhaps a blockchain, right? Because it's like in a very constrained and specific type of programming environment, and perhaps like it makes sense that you want to have like special preference for like certain types of like abstractions. And I know there's a few blockchains that have perhaps like consider different like they have built in some different types of either like account name spacing, I think like in Near, and some other ones where maybe also have like specific kind of more like low level structures for thinking about like assets and that type of thing.
So I think the right place to start is just with that idea of a resource in Cadence, right? And so Cadence I think the easiest way to come at it is that we call it resource-oriented programming, but that it is influenced by object-oriented programming. And one way to think about a resource is that you define a resource the way you would define an object in a sort of an object programming language. And so it has the sort of the nature of the abstraction that objects give you, right? Where you have private data members, you have private methods that, having a reference to that object doesn't mean that you can call those functions on that object, right? That there's an access control component to that. But critically, you can't call functions on that object unless you have a reference to it. And that's the essence of the sort of control, ownership, security model in Flow, where, and just the easiest example, and obviously it's close to my heart, is an NFT. What is an NFT on Flow? It's literally just a data structure, right? So if you wanted to represent CryptoKitties on Flow, you would just define a data structure called a kitty, and it would have, its genes, its appearance, its, the reference to its parents and things like that. But instead of that being just a struct that is stored in a dictionary, as it is in the Solidity on Ethereum, that data structure actually goes into your account. So when you own a CryptoKitty, it's stored inside your account, almost like a home directory of your computer. And so you can have all of your CryptoKitties together in one, what we call collection, like a directory. You could have two different directories where all of your CryptoKitties are stored, because the ownership of your CryptoKitties is defined by the fact that they are inside your storage area, not that they are referencing your account ID. And one of the, so I guess the first thing that is really cool about that is that it means it's very obvious and natural for objects to own other objects. So you could imagine defining CryptoKitties such that they own clothes, and clothes themselves can be an NFT, and you can own clothes independently of the kitties. But if you want the kitty to own the clothes, you literally just take the clothing NFT and you give it to the kitty NFT, and it owns it. And then when I transfer the kitty NFT, because that's literally one data structure containing another data structure, the clothes go with that kitty, and the ownership of those clothes change transitively because the kitty is moved. And so that's a really powerful technique. The other thing that's really interesting is that because it's a data structure, the problem of delegation, right? And maybe you can actually talk about this a little bit in Solidity. One of the problems I always had in Solidity, and frustrations I had in Solidity, was that it was hard to delegate temporary control to a smart contract, right? So, for example, if I want to go to a smart contract and say I want to spend $10 to have this smart contract do something on my behalf, there's no way to do that in a single transaction in Solidity. What I have to do is in one transaction, I have to say that smart contract over there is allowed to take $10 from me, right? So I go to the ERC20 contract and I say, hey, you should allow that smart contract over there to take $10 from me. Then I go to the second smart contract and I say, okay, do this thing. And then it tries to take $10 from me. And if it succeeds, it does the thing. That requires me to have it requires me to have two transactions, which puts extra load on the network. And two, it requires me to have a level of trust of that second smart contract, which is very high, right? I have to know that there isn't a backdoor in that smart contract that allows the creator of that smart contract to just take the $10 before I have a chance to send the second transaction. If the operation that I ask it to do fails in some way, I have to trust that smart contract isn't going to still just take the $10 because I sort of pre-approved the $10. And in Cadence, all of these problems go away because what happens is the transaction starts by taking $10 out of my account as a data structure. And so in a sense, the transaction owns those $10 at that point in time. That transaction then goes to the smart contract and it says, here's the $10. I'm passing you $10 as an argument, right? It literally is an argument of the function. And then it does its thing. And then when that function returns, either it returns another object or it makes some state change that I can query. As the transaction that the user signed, I can say, did you do what I asked you to do? And if not, I can call abort. And just as in Ethereum, in Flow, when you abort the whole transaction up to taking the $10 out of the account. And so if the smart contract doesn't do what I expected it to do, then the transaction has the ability in a post condition to abort the whole transaction and say, you know what, this didn't work out. I have the ability to reverse this all, and I know for a certainty, because it's guaranteed by the system, not by the smart contract, that $10 will never will move to an alternate reality where that $10 never came out of my account. And so it gives a lot of flexibility to, it gives a lot of power to users, but it also gives like wild levels of flexibility to smart contract developers, because now, or more correctly, transaction constructors, because now I can start to combine multiple smart contracts calling multiple smart contracts in a single transaction, knowing that if I'm calling into a new smart contract that uses a standard interface that I've never interacted with before, I can still look at the result of that and know whether or not it did what I asked it to do, and so I don't have to actually review it. I don't know if you followed all of that. I dropped a lot there all at once.
Yeah, I mean, what I'm getting here is that there's perhaps some sort of like there's a hierarchical like permissions structure.
It's not even permissions in a weird way, because it's literally the ownership is where that data structure lives at that time. So if you're familiar with Rust, it has a notion of linear types where you have an object in a function and you pass it as an argument down. Now, the reason Rust does that is for memory management, right? I've got this object that I've allocated on the heap, and I'm going to pass that object as an argument to a function. Well, now, do I have to free up that object, or is the thing I'm going to pass it to call free on that object and free up the memory? Unfortunately, to make this discussion to confuse this discussion, we call that ownership, right? Like who's responsible for freeing up memory is often called ownership when we're talking about it. And so they're tracking a different kind of ownership, right? It's the responsibility to free up the memory, but that's exactly what linear types do. And so you can define an argument, a function in Rust that says, when I put this object as an argument to this function, I, as the caller, no longer have access to that, and I can't even dereference the pointer into it anymore, right? And we've adopted that same idea. And so when I put that data structure representing the $20 as an argument into that function, that variable is no longer valid in the state of the caller. And so it's not even like, at some level, yeah, you could say it's fine-grained permissions, but it's more like me handing a $20 bill in rather than me saying, hey, here's my account, here's a note that you can give the bank that says you're allowed to withdraw $20. It's like you understand how it's not even, it has the effect of fine-grained permissions without the complexity of it.
Because like each account can, you're saying like the structure of accounts like can forget what you said, like the first pass of like owning, you could own multiple objects or multiple traits or like different data structures, or I forget exactly how you put it in initially when you're talking about like how the account model is different than Ethereum.
Yeah, you can think of it as it's sort of like, one way to think of your account is it's a dictionary that you control, right? And then you have a key, a string key, and then a value. And that value can be anything, right? And in the case of an NFT, that's the CryptoKitty. And so my account is a dictionary, and I have a key on it, which is like kitty number 7. And then if I want to do something with kitty number 7, I can go and get it out of that dictionary. But when I pull it out of that dictionary, it's now no longer in that dictionary. This isn't a reference. I don't have a pointer to it. I mean, we do have the power. We do have support for pointers, but just for the purpose of this conversation. And so if I take and I put that kitty into a smart contract that does, say, a lending protocol, right? That kitty now the data structure literally moved out of my account onto the stack, and then down the stack into the lending contract, and then the lending contract is going to put it in its private dictionary. And now it's going to give me like a coupon, right, that represents the lending contract that lets me to go and retrieve that kitty when the loan period is over, provided I'm able to supply the collateral. But now I don't have the kitty anymore. They have the kitty. And the kitty is physically stored in that smart contract's account now.
Okay, so as opposed to like, in let's say the ERC 721 model, where you have like all of the tokens, let's say, are existing within the 721 contract, but their ownership is associated with different accounts.
That's right.
Perhaps if I delegate, like lend it out, so I'm like transferring ownership within the 721 contract to, let's say, an external smart contract that abides by certain rules, and you hopefully have checked them to know that like under certain conditions I may get this thing back. You're saying in this case you're always dealing with like the raw data structure itself. So if I make a So let's say I have like all these CryptoKitties in like this initial contract, and then once I move the CryptoKitty out of this data structure, or like once I buy it, let's say, or like it gets transferred to me, then that data structure on chain becomes associated with my account, as opposed to the like changing of the record of ownership in the smart contract, as would be the case in like the Ethereum.
Yeah, you could almost.
Can I jump in real quick?
Yeah, go ahead.
So I think you gave an analogy yesterday that I thought was really interesting. And just to maybe, dumb it down a little bit for the audience, and maybe myself. You said the difference would be in the account model, which is on Flow. Like you have your CryptoKitty, it's equivalent to handing somebody a $20 bill. You have the $20 bill in your wallet and they give it to you, as opposed to saying, like I think you mentioned earlier, like, oh, I have $20 in my bank. They'll change the ledger to say that now you have $20 in your bank as well. But the money has always been in the bank, essentially, right? It's on their ledger. You don't have it. Is that an apt analogy?
No, that's exactly right. So instead of you and I going to the CryptoKitty store and saying, okay, please write Lewis's number down next to the, CryptoKitty number 72 instead of Dieter's name, I just physically hand you the CryptoKitty and now it's in your account, right? What's interesting about that is that there's a lot of talk about parallel transaction execution right now. I know there's a team that's working on that for EVM. There's a bunch of stuff in Flow that requires less state contention because of that, right? So if you and I were trading a CryptoKitty at the same time as Matt and Anthony, we would be both, like in the EVM world, we would both be calling into the CryptoKitty smart contract. We'd be updating state in the CryptoKitty smart contract, and so our transactions couldn't execute in parallel because there's a conflict there. Whereas in the Cadence model, I'm taking a data structure from my account, I'm sending it to your account. Even if you call code on the CryptoKitty, right? Check its traits to make sure it's the one that you said it was going to be blue, have blue eyes. Let me, in the smart contract, I'm going to check and make sure it has blue eyes before I accept it. It's still, there's no data overlap because you're looking in the one CryptoKitty data structure, they're looking in a different CryptoKitty data structure. So there's no conflict.
So there's only a potential conflict if we're ever calling like the same contract or data structure.
The same data structure, not just the same contract.
Right. And so that allows you to like, perhaps like, let's say, send these transactions in parallel because we're dealing with like now different data structures. But like, let's say from the CryptoKitties contract, what infrastructure is there to like take care of, let's say, I don't know, like tracking these things on chain, or, like being a central source of understanding of, where these things are living on chain. So there must be some sort of like index, I imagine, that you can reference to say like, okay, where are these CryptoKitties now?
So there is, right? But interestingly enough, what this model does is it optimizes for a different kind of case than the Ethereum model, right? The Ethereum model, it's like, hey, I want to know who owns every CryptoKitty. That's very efficient. You go to the CryptoKitty smart contract, you run through, you just ask it who owns number 1, who owns number 2, who owns number 3, and you can run through that. Obviously, you're not actually submitting transactions, you're doing that off-chain queries, but then you can build a database of who owns every CryptoKitty. Great, right? And if you're building a website like OpenSea where you want to show who owns all the CryptoKitties, that's fantastic. Not so fantastic is, well, what NFTs do I own, right? Dete Shirley, my wallet wants to tell me what NFTs I own. What does it have to do? Well, it doesn't. It has to look at every single NFT smart contract that was ever deployed by anyone and see if my name goes up next to it, right? So in practice, they don't actually do that. In practice, what they do is they either build their own index or they strike a deal with somebody who runs an index that has the complete ownership of all of all NFTs by all accounts, right? And so we do that off-chain indexing. Cadence is optimized for the exact opposite, which is, how do I know what NFTs I own? Look at my account. It's just right there, right? It's like, how do you know what files are in your directory? You type ls, they're all right there. You don't have to go to like some database and say, well, where are all the Word documents? Where are all the Excel documents, right? They're all just right there. And so when you are building something, and obviously we had to solve this with Top Shot, right? Top Shot's built on top of Flow, and we want to keep track of who owns all of the NFTs. And so just like an Ethereum, there are events when things move. And so when I move my CryptoKitty from my account to your account, there's an event that is emitted that says, hey, it was taken out of storage in Dieter's account. And then later in that same transaction, it was put into storage in Lewis's account. And then the back end of some website somewhere that wants to create that index can say, oh, okay, now I know where that kitty is.
Sure. And let's say you wanted to like create some logic that was like, okay, only perform such an action if this person owns a CryptoKitty, right? Let's, a Flow Kitty or XYZ. So how would you check that? How would you, because presumably there has to be like a definition of what, an XYZ kitty is, right? That like stems back to its point of origin, let's say, like some permission structure that defines what an XYZ kitty is. Now, if all these data structures kind of like shatter and are being passed around different contracts, so where does that metadata lie? Is it still like within each object? There's like each object carries like the unique identifier metadata of its origin, or is it there's perhaps like the contract where these things were deployed has that information and you reference that?
Yeah, so it's we surface it as type information, right? And so any object, you can ask it what its type is, and the fully qualified type of any object in Cadence is the account where that contract that defined that type is hosted, the name of that contract that defined it within that account, and then the name of the type inside that contract. And so if you take an NFT, a CryptoKitties NFT, and say, what is your type, right? If you print that out, you get an address dot CryptoKitties dot NFT, right? And so you can track it back that way. The question about like, how do I prove that I own a particular kitty? This is where we start to get to pointers, right? So one way to do that would be just to pass the kitty in as an argument and say, well, here, like, let me hand you the kitty to prove that I have it. You like, I'm passing it as an argument, and then you pass it, and then I expect you to return it back. And guess what? If you don't return it back, then I abort the transaction, right? But we recognize that was an important use case, and so that was one of the reasons why we created the ability to pass in references to objects as well. And so I can pass a read-only reference of that kitty as an argument to a function. And so let's say you're the smart contract. You're like, hey, I'm doing this promotion, or I'm doing an airdrop, and I'm going to give 5 tokens to everybody who has a blue-eyed kitty. I'm like, great. Here's a reference to my kitty. It's a read-only reference, so you can query it, find out whether or not it has blue eyes, but you can't modify it, you can't breed with it, and you can't change ownership of it because I'm only passing you a pointer, right? A reference to it. I'm not passing you the whole thing. But because all of this is part of the runtime, you can ask that thing, what is your type, right? Like fully dynamic type information. Does that exactly equal the CryptoKitties type? And when I call that function, iColor, does it return blue, right? And in the same way that inside of a language like C++, that when you ask the type system what is the type of this thing, that it's going to be accurate because the language itself is the one that's managing that. I'm not calling a smart contract and asking it, give me a string, which is your type. I'm asking the runtime, what is the type of this object that I'm looking at?
Right. So if I understand correctly, then to piece together, the data and metadata for like the actions and objects on chain, there's a combination of like the metadata contained within particular like data structures, right? So because within that metadata is perhaps it's like its point of origin and like other useful information, plus with like an off-chain indexing service that will say like, okay, here's like the complete historical like record of transforms and like other traits and so forth. So if I wanted to say like okay, how many items in this collection possess a certain trait, for instance, then that would be like something I could like index, like query off chain. But then also, okay, so let's say I wanted to do that on chain to be like, okay, within a calculation, I want to see, like how many items within this collection possess a certain trait. So presumably, then like if I just have this one item from that collection, right? So let's say I have the metadata, and within that metadata is also like is the metadata of the individual object, or like where and when does that like separate from, let's say, like the metadata of the like originating contract? And then would I need to kind of like trace back from that, object to its source, and then, okay, here's like a list of all the objects, and then like run some calculation to say like, okay, which one of these objects like possesses a certain trait, or could you create, let's say for these types of purposes, let's say even in like Solidity, it becomes unwieldy. So people make, like some sort of special like indexing function where it's like, okay, it's actually very difficult to say how many kitties have blue eyes, let's say, within the context of a calculation. But so you can do like, some sort of like reverse mapping or like lookup function to be like, okay, we're tracking the number of blue eyes such that like every time someone needs to reference that, we have like a very like quick data structure, that like makes that information like more accessible.
So that's an area where the two languages would be quite similar, right? Where if now Cadence typically has a larger compute budget than a Solidity transaction does, but I mean, more or less the computation limit of a single Cadence transaction is about the computation limit of a single Ethereum block. And so we're doing 1 block per second. So we have lots more throughput than Ethereum. And so it's more tractable to do a loop over a large number of items, but it's still not the right answer if it's starting to get complex. So again, you would build that index. So if it was important for you to be able to look up by blue eyes, then you would build that index into the smart contract, same as Solidity.
And then if let's say if that was part of a smart contract, and let's say, we're both transferring our objects, but like within the scope of the transfer, we wanted to like reference this function, then would that be like a conflict with like the parallelism like only occurs insofar as there's no like mutual, there's no function calling between us to like the same contract. Is that
the same data, yeah. So to go back to your example, right? Like if we were to have a data structure that was like, well, just list I just want a list of all of the cats with blue eyes. You wouldn't then say, well, it's Matt's cat. You would say it's cat number 24, right? And so when Matt was sending his cat to Anthony, you wouldn't need to update that database because now cat number 24 lives in Anthony's account, but it's still cat 24, right? And so we don't actually run into that problem in that particular example. But you're absolutely right. Like if there was, like for example, for a while there, and we actually removed it for this exact issue, we would keep track of how many tokens there were, total number of tokens, flow tokens there were as a static variable in the smart contract. And if you, whenever you deleted an object that can hold tokens, and we call it a vault, we would update that variable. Well, you delete vaults all the time that have 0 tokens in them, and so that we would be constantly subtracting 0 from that variable, and so we just got rid of that logic.
I have a bit of a 2-part question. So, Dete, you mentioned that EVM wallets have to index the entire like EVM chain and basically like look through every single. So when I'm looking at my MetaMask on my phone, whatever, and it says I have these NFTs, they off-chain indexed the entire chain and said, oh, your name appeared here, 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 and here.
Mm-hmm.
Okay, that's just interesting to me. I guess I wouldn't have assumed that's how it worked. I would have assumed that like these objects exist inside my wallet, or yeah, that's just weird to conceptualize.
Yeah,
it's just weird to conceptualize that because it doesn't feel like a wallet. It feels more like a a list or something. I don't know. Like, so I'll ask, like, Lewis, to you, you've been on the EVM scene for a while. Like, when you understood that, did that surprise you as far as like, do you consider that ownership, or is that just kind of like the cost of doing business, or is it a non-issue at all? I don't know. Like, as an end user, I kind of like, that's interesting. But
And, I'll answer in a classical like EVM way. Like, what is ownership?
right. No, for sure. That's, I'm like, yeah, it begs the question entirely.
And it's like, is it like control, and access control? Like, what data in this data structure do I have either like complete or partial control over? Like, what type of control? So then if that can be defined in like so many different ways, then perhaps like, they say like, ownership is your key, like, because your key gives you access to your account, and your account is referenced in all of these data structures. And these data structures say like, okay, only this account can perform such a function concerning this data. And so then, okay, there's like some type of ownership there. Yeah. I mean, similarly to like, when you think of a wallet, right? Because all of these terms are like path dependent. And like most of the value in your wallet, if you open it up, is probably in like a piece of plastic. And that's still there, it's like goes to some occluded database with like all sorts of references and various levels of ownership, or, perhaps borrowing and these types of abstractions, So in that sense, like ownership is effective. But maybe when we're talking in the blockchain context, it means something way more like specific, or let's say like computational, like, who can actually control something. Or maybe more specifically, like which key, like whoever owns which key or which NFT, which data structure, can like control other pieces of data. And so I think that's what we're thinking of in ownership. And here, it's interesting to think about, let's say, like obviously it's thought a lot about like the, like the abstractions of ownership and how they're like emergent in this context of, say, like digital assets, for instance, right? And like what abstractions might be more useful, or like what abstractions can be more like efficient and elicit like new and different types of design patterns, right? So I think this is like an interesting to think through, like what like how you could change up like the abstractions for which like ownership is like considered. But I imagine like even on this chain, right, there's still like this idea of ownership in terms of access control is still part of perhaps like possible logic within the contract.
Yeah, I mean they're tied together, right? And obviously they're tied together on Ethereum as well. But like it's like we don't have the notion of message sender in Cadence. We don't know who's calling the function, and it's all about who has access to that object, and that is the primitive for both ownership and access control. So from like the standpoint of access control, like if we go back to the example I gave where you put your NFT in a lending protocol. So you put your NFT in the lending protocol, it gives you back some tokens for that you're borrowing against that asset. But then it would also give you back like a claim ticket. And that claim ticket is literally an object that you can store in your account. And that is and then if you want to manage that loan, right, either, maybe the platform lets you take out more money if the price of the NFT is expected to go up, or even just you're done and you want to pay off the loan, that object lives in your account. And so what that means is that the logic, as a developer of that platform, the lending platform, I don't have to manage like, oh, well, how many loans are there for this account? So this person's calling me, and then they have to pass in an argument indicating which loan they're talking about. And then if they happen to have two accounts and they call from the wrong account about a certain loan and they try, I can't map it. In Cadence, it's very straightforward, right? I literally gave you an object. It lives in your account. You want to put money in that, on that loan, you literally pass money as an argument to a function on that object, and that helps pay it back, right? And when it's paid back, how do you get your NFT? You literally call that a function on that object and say, give me back my NFT. And that NFT is sucked out of the the lending contract through that object, and then I can put it wherever I want then. And so, I liked what you said there, because I actually agree with you 100%. Like when I hear people, I often hear users on Flow finding out that their assets actually live in their account rather than in a smart contract. And I hear them get very excited. And I'm like, I'm glad you're excited, but like at the end of the day, like that's not really what defines ownership. And so I think it's viscerally, it is appealing to people. But the reason why I wanted it to happen, I think that's a great happy side effect, but the reason I wanted it to happen is because as a programmer, it's so much easier to keep track of. And it means that there are way fewer opportunities for an error. We're right now designing a smart contract to do a program on Flow where you can lock up some tokens and get some rewards as a way to like bootstrap people using the platform. And what's wild is that when people come and say, I want to lock up these tokens, what we can do is we take their tokens and we put them inside another object, and then we give them right back to them. And so where do their locked tokens live? In their account, right? Now, again, you can make the argument that, look, ownership is about control, and if it's in that locked object, and even though that object's in your account, but it's wrapped inside this other object that won't let you access it until such and such a time, et cetera, but like, so maybe from like a practical standpoint of like true ownership and whatnot, it doesn't matter so much. But from a developer standpoint of managing the logic of that, I know as a programmer, I literally can't write a bug that returns more money than you gave me, because the pool from which I am drawing is literally your money. It's not everybody's money altogether. And so even if there is a bug that lets you withdraw twice, it's still going to fail the second time, because the money is literally in there. It's not some pool of money that which we're separately tracking how much is yours. And so that's I think I want to try and remember that phrase of yours, because I think it's the power of the abstractions to let the programmer not have to worry about certain complexities and let them focus on other complexities. That is where I get really excited about this model.
A quick thing I really like. I like that you are redefining, like questioning like the ownership question, like what is it like before trying to grow this concept too far. And then I like that you're pointing out like the aspect of like access control and saying like which is part of the concept. And access control on Flow is also something that I think is interesting. Is kind of like, okay, you have those resources in your account, and then you can enable X, Y, Z access for X, Y, Z different account. So it's also a way to say, like, for example, I can give access, like you can view what I have on this resource. You can just view it, but you cannot manage it. Or you can go to the doctor and share a specific part of your file and not just the entire history. But also when you're part of a game, you can share like, I don't know, one specific token vault and not just the entire access to your model. I'm not sure I'm being really technically accurate right now, but potentially I'm saying a lot of bullshit. But the point that I want to make is the access control things and how like you try to rework on that and rethink about the what we call capabilities, right? Yeah, I mean, like if we could like just dig a little bit deeper on that, and then after that, I would love to address a little bit like what you are building right now, and potentially how we can like figure it out, that this idea that is super interesting about AI agent, decentralized application, and how we can potentially like do like a quick like playground workshop right here, right there, to see how we could like potentially launch it on Flow, and how can Flow can benefit, how like this idea can benefit from the tech, and how we can obviously benefit from contribution. But yeah, capabilities and and access control. What's your? Could you define a little bit more this concept?
Yeah, so I I lied a little earlier. I simplified a little earlier when I said that I one of the things you can do is pass a read-only reference to the CryptoKitty, and then they can look at it. It's actually a little bit more nuanced than that. We have this notion of entitlements in the language, and what the entitlement does is it defines a facet, which is a set of functions that can be called. And typically they're associated with a particular role, right? And so, like, fundamentally, the reason this exists is because, as programmers, we're all really comfortable with the idea of a mutable reference, a constant reference, and if you give me a constant reference, I can look at it, but I can't change it. If you give me a mutable reference, I can change it, right? It turns out that in the blockchain world, that's not nuanced enough, right? If I give you a reference to my tokens, right? You might say, oh, well, giving you a mutable reference to that would be a terrible idea. I'm like, well, not if you want to deposit some money, right? Giving you a mutable reference where you can deposit coins is actually really quite common and useful and isn't a security issue, right? And so what I don't want to, and if I give you a constant reference, you can't deposit tokens. So how do I let you deposit tokens? Well, I can't give you a mutable reference because then maybe you'd steal it, right? And so we have this more nuanced idea called entitlements. And the entitlements is basically a list of functions that can be called with a name associated with it. And when I give you a reference, I give you one or more of those entitlements. And then again, the language, the runtime itself, makes sure that you're only able to call functions through that pointer with those entitlements, right? Now, then we have the other notion of capabilities. And what capabilities are is references that persist between transactions. And the reason why this is important is that I might want to give you a reference to my kitty to eat, maybe even to breed with it in the course of a transaction, right? So I've got a really valuable kitty with awesome genetic material. You want to breed with it. So I'm like, great, here's a reference to my kitty. Your kitty can be impregnated by my kitty. And so I'm going to give you this reference. And the fact that that reference isn't storable means now I don't have to worry about you coming back in 6 months and stealing my sire's valuable genetic material without us coming to a new agreement, right? On the other hand, there are times when, for example, I'm the administrator of some DEX and I need to be able to change certain parameters. I need to be able to have a reference to the administrator object that does persist. And so we call those objects capabilities. And so a capability is a latent reference that I can reuse between transactions and is long-lived. And then a normal reference just goes away at the end of the transaction. And then they're both attenuated through this notion of entitlements so that that's where we have very fine-grained access control where I can say, here are exactly the things that you can do. And, an example I gave was that I give my accountant the ability to see all my transactions, but I give my personal assistant the ability to pay bills out of my account, but actually they can't see all of my transactions, right? So that idea of more nuance beyond just read only or read write is really valuable.
There's something about discussing these like blockchain topics in the context of like my digital cat's going to breed with your cat. I think this is really
Very little point.
Well, I guess that's where it all started.
Absolutely.
Breaking the chain with, it's something like a system where like cats can't die, but they like reproduce kind of geometrically. Almost as like designed out of the gate to cause some sort of clogging problem.
And weirdly, it didn't even occur to us. And there are two reasons it didn't occur to us. One, like we were terrified that no one would care. And it never occurred to us that it would be, like we were hoping for moderate success. We didn't even imagine wild success. But also, we'd never done the math. Like we had done the math to make sure that the transactions weren't too expensive, but we'd never done the math to say, well, how many of these can you do in a block? And how many users would it take to sort of get to a significant percentage of a block? And, the way I always tell it is that like, it was 2017, right? People were doing ICOs claiming to like, we're going to disrupt the real estate industry. We're going to disrupt the insurance industry. We're, going to replace, Visa. And then I'm like, okay, great. Like I didn't think my cat game was going to break the whole network, right? And so you're right. Like in retrospect, like the fact that these cats live forever and
I mean, it was
and they just reproduce.
Brilliant marketing, like incredible.
It's probably true. I think if it hadn't been as bad, it wouldn't have been as good.
Yeah, it's definitely a feature more than a bug.
Yeah. And that was that was a fundamental problem with a light topic. And when you're tackling anything like complex problem, you want to use like a really easy topic, because otherwise you were just adding complexity on top of a complex problem. So, and cats and internet, it's something that
Cats and the internet.
we were chatting about. We were having a drink a couple days ago, and I started to speak to you with about like a couple of features I was excited about regarding what you are working on right now. And so that's not a bit completely linked, but also independent to like the big upgrade that we're gonna do, like called Crescendo, creating this EVM zone, and also like bringing a new version for the language. We call that Cadence 1.0. And so in this whole new upgrade, I didn't do shit, but they worked on like a whole research on when we were speaking about this. So like this whole new upgrade, like, well, let us like bring this like. So I'm not specifically excited about the tech because I'm not sure I fully understand it, but I'm really excited about the ability behind, and like what enables this is. They call it scripted transaction, but we are still like debating internally. So some people hate scripted transaction, some people call it atomic transaction. We are the real value is in their work, is not really the name, and we will figure out a great name so that people can understand. Potentially, you can name it and you can define the name with us today. It's a way to, when you launch transaction, you can put like many different actions in the same transactions, so that you can like, it brings like a couple of advantages. So like, first, like you can scale like the ability of the transaction because you are doing like many actions in the same one. Also, you can also make sure that like kind of like if you have many different conditions that you want to achieve at the same time, you can do it all at once. And if you mix that with the like post-condition model that we have, it's kind of like create also like a precondition before the transaction. You create a post-transaction post-condition after the transaction. And so what enables that is I think why it was like interesting about this is that it's kind of like you can run a more complex on-chain logic, and also with like condition pre and post. So that, for example, like you can imagine like crazy use case for DeFi. You can run like you can create like crazy arbitrage leveraging this kind of techniques. And so you were explaining me the work you're doing right now, and I would love to, if you agree, like we can share and discuss this.
Sure.
Together.
Yeah, I have a little bit of time left, and I think we can cover this. I think it's actually interesting to me to explore as well, because like very briefly, been thinking about like agents, and as we talked about, like kind of how agents like coordinate and like compose their actions together, and thinking about using the chain as like one of the fundamental layers by which like agents like form commitments and coordinate their actions. And naturally, let's say as these things, as like agentic systems and the agreements and contracts they form become more complex, then there's like all sorts of like, complex like pre and post conditions, and like, let's say multiple parties all on the line at any given point for essentially one like data structure, but then may have like a lot of like nuance in between. For example, it's like if a bunch of agents come together and all agree, okay, we're all independently gonna perform these actions, come back, like share resources, and maybe there's like an evaluation layer of like some other agent or arbitration process to like make sure everything was done. Or maybe there's also some like verified inference thrown in, which adds like, okay, preconditions, like was this computation run correctly? Okay, if so, then like, continue, or if not, create some sort of like failure condition. Maybe a failure condition doesn't terminate an entire like contract between agents, but only part of it. I think there's perhaps some like overlap in thinking there of this kind of like scripted transactions idea, right? Of like having a more, essentially building a contract, like a transaction as a contract, right? That like itself, is like can have its own like internal logic, right? Of how you deal with like multiple conditions of transactions at the same time, perhaps with like different parties like inputting in different areas. And thinking about how that fits into your more, like deeply like account abstracted like architecture.
Yeah, it's so we're working on right now. There's a design we're working on, what we call we're internally calling, and come back to Anthony's point about us not having great naming, or at least me not having great naming. But right now we're designing a thing that we call the extended transaction format, which I want to tell you about in a minute, because it's like it does exactly what you want. But today our current transaction format is still, I think, very powerful in that each transaction can be signed by multiple accounts. And so you and I could prepare a transaction, or our agents could prepare a transaction together that has access to the assets in my account and the assets in your account, but we both have to sign it. And so we don't have to set up a smart contract or anything like that. We can just do it on a transaction basis. And the reason why the value of that is obvious, right? Like you and I could decide to do like a three-way swap where I'm going to trade one CryptoKitty and 2 Top Shots for your Marvel collectibles and an NFL all day moment. And rather than us like going to some smart contract and doing that, we just prepare a transaction that takes those 2 things out of your account and puts them in my account, takes those 3 things out of my account, puts them in your account. And as humans, right, like we could literally both read that transaction, see that that's what's happening, go to our wallets and say, yeah, I want you to sign this thing. They want to send that thing, and we set it to the blockchain. And that transaction has the ability to access both of our accounts because we both signed it. Now, generalizing that, so that's very powerful, but that also leads to much more powerful like spoofing attacks, right? Where you slip in like an extra line that I don't notice, that you're actually pulling out a 4th NFT that I didn't notice, right? And or pulling out some of my USDC at the same time. And so the way we try and solve that is by having a prepare statement, which is intended to be simple and easily analyzed. And it's only that section of the code that actually has access to the accounts, right? So when you sign a transaction, it has access to everything in your account. Well, that's not great, because if the transaction is very complex, how do I know that some of that code in the more complex part isn't going to mess with something I don't want it to? And so what we do is we say, look, if there's something you want to take out of the account, you have to do it in this prepare statement. And then we can put restrictions on that prepare statement and say, look, you can't have loops in there. You can't have, a bunch of function calls in there. All you can do is just pull assets out, store them in temporary variables, and then we run the main body of the transaction, which is arbitrary code. It can have loops. It can call multiple functions. It can talk to 5 different smart contracts, but it now no longer has access to the contents of our accounts. It only has access to the assets that we pulled out in that prepare statement. And then the third section is the post condition, and the post condition, it can do whatever you want. You can, in my case, it would be like, well, did he actually deposit, those 2 things? Are those 2 things actually in my account? You might want to add the post condition. Are those 3 things that Dieter promised me actually in my account? And if any of those post conditions fail, the whole transaction aborts, and it's a complete rollback. And it's as though nothing happened except for the gas being paid. So that's what we have right now, and that's already, I think, incredibly powerful. And then by putting that prepare statement, we allow for an easier security model where, as a wallet, I only have to analyze the prepare statement, and I don't have to analyze the body of the transaction. Where we want to get to is, in the extended transaction format, is to get to the point where instead of you and I, there being one giant prepare statement, and you analyze it and make sure that the parts where it touches your account you're happy with, and I analyze it to touch the parts that I'm happy with, we each get our own prepare statement. And my prepare statement pulls things out of my account and doesn't even have access to your account. The thing that I'm signing touches my account, but can't touch your account. So I can't inject any code. And then your wallet creates the prepare statement. It doesn't scan the prepare statement and try and make sure it's safe. Your wallet actually generates the prepare statement that pulls those 2 NFTs out of your account, signs it, and then adds it to the transaction. And then in the post condition, again, we each get our own post condition that we sign, and our post conditions run. And if either of them fail, then the whole thing aborts. And what this allows is you could imagine a very powerful mechanism where I'm like, look, I want these 3 NFTs. And you're like, well, I only have 2 of those, but I think the third one's up for sale. And I'm like, great. I'm going to take 50 USDC out of my account and the 2 NFTs you want and put them in this transaction. You're going to take the 2 NFTs that you have, take them out, put them in your transaction. And then the body of the transaction can go and try and buy that thing. And what's cool is that because if we trust the prepare statements and we trust the post conditions, the body can do whatever it wants. It can go in and check 3 different NFT marketplaces and find the NFT, the NFT that matches the requirements up for sale. It can notice, the body of the transaction can say, oh my God, it's for sale in Flow token, and all I've got is USDC, so I'm going to run to a DEX, swap it into Flow token, and buy that NFT, and then I'm going to put it in. Oh, actually, it's on a lending protocol, but fortunately, the person who borrowed it is in arrears, and we can actually liquidate them and get that NFT for the Flow tokens. And all of that happens, and then when we get to the end, it doesn't matter how complex that execute statement is. Either you got the 3 NFTs you wanted, I got the 3 NFTs I wanted, or the transaction gets aborted. And what's amazing is that even though I might have gone to the DEX, I don't have to unwind. I don't have to take the spread when I unwind that position because it's aborted. And so it's as though the USDC never came out of my account. And so it allows. And that's just NFT trading, right? Imagine more complex things.
Right. And what I would think is on top of what you said, what occurs to me is potentially very interesting, or like kind of partially signed scripted transactions where you have, let's say, I'm putting up certain assets and I expect to get perhaps no less than whatever my like post condition variables are, and maybe there's even some logic there. I'll take this or this, but no less than a certain amount. I actually don't care what happens in the middle of the logic. Maybe there's like some other composer out there, but as long as perhaps like I delegate out, like the permissions to like manipulate my assets in a certain way, as long as I get, some sort of minimum floor, which creates perhaps like a really interesting kind of like 2-sided marketplace for like transaction composition. And I think I find that as like an interesting notion to explore on top of this idea.
I think it's very powerful, and I think there's at least one, maybe more proposals for blockchains built around this idea of intents. And I don't think it needs to be a new blockchain, but I think it is incredibly powerful. And I agree, especially when we start talking about agents where, like, the model we have now actually can work with agents, provided the agents are able to talk to each other and sort of come to an agreement, and then, do that analysis I said, where they check the post condition, check the prepare statement, and make sure that it's viable. Then even the execute they can mostly ignore. But I think if we can get to that point where you can safely submit a prepare and a post without any body to it at all, just sort of like, look, this transaction will pull these assets out of my account, but that transaction will be aborted if these assets don't end up in my account at the end of it. Go nuts. Trade with me, right? Figure that out. And you can imagine like a completely off-chain mechanism for matching those up, and even matching up multiple, right? Where like, oh, you want X and you want Y. You're willing to give up X in exchange for Y, and you're willing to give up Y in exchange for Z, and you're willing to give up Z in exchange for X. We put all three of those together, and it works.
And that's fair, because like you were I mean, tell me if I'm wrong, but like you were potentially mentioning that like the fun part also of this experiment would be just also to like set up quickly the parameter of X, Y, Z agent, and then let them just interact and potentially like identify sort of like common patterns, or see what happened at the end, like regarding the different setup the parameters that you did at the beginning. And I was thinking like potentially if you if you do this kind of experiment, that will mean like a lot of actions, a lot of transactions, a lot of things to handle. And so I was potentially thinking like that you can, and that will be the last potentially topic that we can address, but you can you can increase the number of actions, and also increase the control of the input and output, and the things you want to do with the extended transaction model. You can also potentially like embed some EVM transaction directly into like a Cadence transaction, so that you can, as long as you're not reaching the block size, you can nest like many more transactions, and so potentially like double, triple, how many, 10x, 7x? What was the Vishal computed?
Like 100.
Yeah, okay. But mainly you can nest EVM transaction into a Cadence transaction until you reach the block size.
Well, can we zoom out, right? Because we haven't talked about EVM at all yet, right? And so, I mean, I think if we were to finish this conversation, you would like go home and go, man, those guys are doing something cool. It's a shame I've got a bunch of EVM code that I've already invested in, and that language is fine and all, but like I can't start from scratch again. And that's something that we've heard from lots of developers, where they like some aspect of Flow, whether it's their applications on there, whether it's the way that the actual protocol is built and the decentralization guarantees it has, or even Cadence itself. But they're like, hey, like I have EVM code. What do I do? And so what we're releasing this summer is an EVM embedded inside Cadence, and what's neat about it is we're sort of emulating Ethereum, right? Complete with like block production inside a smart contract. Now, under the hood, it's actually, we're forking Geth code. Like, we're not trying to recreate the EVM in Cadence code. So it's the EVM interpreter is, or execution engine is literally just pulled out of Geth and merged into the Flow code. But from the standpoint of, as a Cadence developer, there is this thing, which is a complete EVM environment that works just like Ethereum, right? Like, you can sign transactions and submit them the same way you normally would. We even have a mechanism where you can use the JSON RPC to submit transactions and make state queries if you have a bunch of off-chain infrastructure that understands EVM. But the thing I'm most proud of in terms of how we did the EVM is that we didn't just say, hey, here's EVM functionality if you want to use EVM functionality, and here's Cadence functionality, right? EVM is inside Cadence. And what you can do inside Cadence is you can say, hey, I want to create an account inside EVM. And that, we call it a COA, a Cadence-owned account. And it's kind of like, from the standpoint of the EVM, it looks like a smart contract to the EVM. But the way the authentication actually works is that you can call any EVM functionality from Cadence through that COA, and it's as though that object is initiating that transaction, right? So you pass in call data, and then it can call any smart contract that it wants. And because that's happening from Cadence, and because Cadence, and this is what Anthony was getting at, because Cadence transaction is a script, you can actually submit a transaction to Flow on the Cadence side, and it might do 100% of its operations inside the EVM, but it can do 5 of them, right? It can do 10 of them. It can do 100 of them inside a single Cadence transaction, where it's where it's calling in and doing these things. And so some of the things I just talked about how how you could go to 3 different dexes and trade and then do the NFT and stuff, all of that could be happening inside the EVM. But if you're wrapping it in a Cadence transaction, you still get all those benefits of the bundling and the pre and post conditions that that you're querying into the EVM. And so I don't know, man, people asked for EVM on Flow for a really long time, and I was like, guys, EVM is just so much worse than Cadence. Why do you want that? And it finally got through my thick skull that they're like, it's not that we love EVM, it's that we've already gone through that pain. Like, why would we give up that asset of all the existing code? And so then the question was, how can we let people leverage that code without them being separate from the advantages that all the hard work we put into building Cadence? And it's really, I think, very exciting and very powerful. And we're hoping to see, we have, teams like OpenSea that are looking to come to Flow now on the EVM side. And one of the things that we want to talk to them about is how they can improve their user experience by just a little touch of Cadence, not even necessarily deploying new smart contracts, just using the transaction format instead of the normal Ethereum transactions will give them a bunch of new interesting capabilities. So it'll be really exciting to see how people are able to make use of that. So I think that really, I'm glad you brought that up, because I think the EVM functionality kind of makes it really exciting, because you can get all of these cool Cadence features while layered on top of the existing EVM code base.
So if I just try to sum it up like really quickly, it's kind of like you take your Solidity code, you copy paste, you change like one endpoint, you hit deploy, it works. And then if you want to extend your Solidity smart contract, you can use Cadence for X, Y, Z reason for the weather we just addressed, right?
Yeah, exactly.
So what are we launching, Luis?
I'm going to have to meditate on all of that. A lot of interesting, in general, I like the idea of, like abstractions over even like the contract and like transaction and asset layer for, specific use cases, DSLs, like making things more kind of sensible and, easier to parse with post and preconditions, all of that's very interesting. Perhaps, we'll have to follow up and, see where maybe, further ideas can take us. Do my research as well.
Yeah, well, I hope you take a look at it. I think you'll find a lot of cool stuff in there.
Thank you.
This is great. Thank you so much for your time. Thank you so much for taking time to chat with us. And I'm actually, my instinct tell me that that's the start of something, and we can have fun in the future. And that's. Do you want to add any kind of last or this, or do you want?
I don't want to throw just a total monkey wrench in this, but I'm like, you're talking about agents on chain. Like, is scaling an issue that you're thinking about, or is it just like we'll go to an L3, L4, yada yada yada?
I mean, I think it's also like highly dependent on the use case. I think an agent is like more like a person in a sense, where it can control like multiple accounts across different layers for different purposes. So I think some things are like agents will go where like the liquidity is, but then in other places they may go where it's like cheap to create, like microtransactions and then bridge to different layers. I think agents have a really kind of like multi-chain potential as a result of that. They're kind of managing like keys across different layers.
No, that's a good point. I just was like, I was curious because we've been talking about AI meets blockchain all weekend. So I figured you had an interesting perspective.
Yeah. So I think precisely, it's like, I think it's very open to think like, they will engage in certain behaviors or maybe certain chains that have like better abstractions for those behaviors, and like kind of be bouncing around different layers as a result.
Now we just got to get the AI to like EVM on Flow.
Yeah, and let's make sure
that's called fine tuning.
Let's make sure that doesn't kill the whole system in the world after that.
We were built for this.
Okay, thank you very much, guys. Let's close the session.
Thanks.